Circular measure. So the syllabus point 9.1 says solve problems involving the arc length and sector area of a circle, including knowledge and use of radian measures. So what that means is you need to know how to solve problems about the arc length and finding sector areas of a circle, as well as knowing how to calculate from degrees to radians and the other way around. So let's just remind ourselves what parts of a circle are. So in this diagram, we can see what an arc of a circle or a part of a circle is, what a sector is, what the radius is, what a segment is, what a chord, and what the center of the circle is. So an arc, sector, or segment is described as either minor if it involves less than half the circle and major if it involves more than half the circle. So here we can see a circle split into a minor segment and a major segment. Similarly, we can see a minor arc because it takes less than half of the perimeter, and a major arc, the red one, that takes more than half of the perimeter, or that is greater than half of the perimeter. So circular measure, let's just remind ourselves that one full revolution makes an angle of 360 degrees, therefore one angle is going to be 1 over 360, or 1 degree is going to be 1 over 360 of 1 revolution. In the radius of a circle r, if the radius of a circle is r, then arc of the length is pi r, or half the circumference, will subdue an angle of pi radians. Therefore, pi radians is 180 degrees. So from there, we can learn that 1 radian is 180 over pi degrees, which is close to 57.3 degrees. And 1 degree is the other way around, so it's going to be pi over 180 radians, which is close to 0.0175 radians. To convert from degrees to radians, we're going to multiply with pi over 180, and to convert from radians to degrees, we're going to multiply by the reciprocal of that, so it's going to be 180 over pi. This diagram here will make it a bit easier for you to remember, and also try to remember that if you can remember rather than remembering the actual values, remember how to remember the formula, and that will help you solve questions a lot faster. So arc length. In the diagram, the arc length is AB is just L, and the angle theta is measured in radians. So we use a ratio to obtain the arc length over the circumference, which is equal to theta over 2 pi. And from that, we can simplify that formula down to L over 2 pi r is, or not simplify, but substitute the left side of the formula to L over 2 pi r is theta 2 pi. And then we're going to multiply left and right with 2 pi to leave us with L over r equals theta, and then the r will be, the left and right side will be multiplied by r. That all happens in this one step here. Will be multiplied by r to leave us with L equals theta r. So for theta in radians, arc length is theta r, and for theta in degrees, arc length is just going to be theta over 360 times 2 pi r. So you can either remember the formulas, or you can just remember how we get that from the ratios. So now we're going to try one question. A sector has a radius of 12 centimeters and an angle of 3 radians. Find its arc length and its area. So pause the video and do it, and I'm just going to show you the answers now. Okay, so to find the arc length, you just use the theta r, which is equal to 3 times 12, which is 36. For the area, you use the other formula, which is half theta r squared, and then you plug in the numbers you know. So it's going to be half times 3 times 12 to the power of 2, which is 216 centimeters squared. So now let's move on to the area of a sector. In the diagram on the left, the area of a minor sector, x and y is shaded and theta is measured in radians. So this is that sector, and we're going to use a ratio similarly to the previous example. We're going to use the ratio, but this time it's going to be the area of the sector over the area of the whole circle, so which is equal to theta over 2 pi. So we're going to just substitute a instead of area of a sector, and area of a circle we're going to substitute with a formula for an area of a circle. Now we're going to rearrange this formula for a, which will give us a equals half theta r squared, and take away from this video that for theta in radians, area of a sector is half theta r squared, and in degrees it's going to be theta over 360 times pi r squared. So now we're just going to test you with a question. So find the area of a sector with the radius 8.2 centimeters and arc length of 13.3. Pause the video and try to do it yourself, and I'm just going to show you the answers now. So for theta in radians, first of all, we're going to use the formula we learned previously, which is L equals theta r. So theta is L over r. That's just rearranged, and 13.3 over 8.2. And then the area, well, you can multiply it by 10 on top and bottom to get you 133 over 82, but it doesn't matter. And then now that you have that, you can use that to find the area. So half theta r squared is the formula for an area, and we're just going to plug in the numbers that we have, and we're going to get 54.5 centimeters squared. Okay, these are some more questions where you can test yourself since the answer's on the right.